Hello, everyone. Good morning, good afternoon, good evening, good day.
Happy time zone.
Happy time zone. We are already seeing a bunch of people hop in, which is awesome. We're just going to give a couple moments for everyone to realize the Zoom started and get everything settled. But it's great to see so many people showing up, and that just means you're excited to hear about this topic. And we're excited to talk about it too, because of course, we went through the trouble putting this together. So that has to count for something.
Some mild amount of bonus points.
So I'm sure you've all been in a Zoom webinar before, but we'll have Q&A available. So if you have any questions or want to share any information with us, you're welcome to use that. I'm not entirely sure if the chat works or not, but if it does, you're welcome to say hi. If it doesn't, too bad. But this is awesome. We have a lot of people. I see a lot of new faces. I see a lot of familiar faces. For those of you who have been to a webinar for that we've done for Hurricane before, welcome back. I'm glad we didn't scare you away too much with the past ones. But for those of you who this is your first webinar, welcome. You're in for a good time, I hope. We try to make this fun and entertaining, but also informative. And that's always our goal. And yeah, we'll just give it another minute and then we'll kick it off. So we'll do that. I do keep seeing the number climb, so that's a good sign that people are filing in and they're getting all squared away. But just to recap, we're happy to take questions that we can answer either during the event or at the end. You can just put your questions in the Q&A box and we'll queue those up to get answered by us. Yeah, I think we're good. So hello, everyone. Welcome. This webinar, we're going to cover talking about designing security use cases. And this is a topic that at Hurricane, we do every day. So we work with a bunch of clients who have security problems that we try to solve, and they want to have security alerts for things. And from our perspective, especially from your perspective, Meredith, we're constantly doing that.
Yeah, and it's always a fun time. So we thought we'd design a webinar to show you our security use case lifecycle and kind of what we do on a daily basis from the back end that you might not get to see every day.
So I'm going to start by taking everyone back in time to June 2023. Now, you're probably like, do I know what I was doing in June 2023? Like me, I don't remember what I was doing yesterday at this time. But June 2023, you might know
So
if
you can go.
no, if you were using a tool called Move It.
It's a fun time. I definitely remember what I was doing in June 2023 because around 5 a.m., right around June 1st or 2nd, we started seeing a bunch of blog posts pop up about a vulnerability and a breach. And then we started seeing disclosures happen over the next week from companies, different government departments stating that, yes, we were leveraging the software and yes, we've been breached too, which was less than a fun time. So, back on the architect side here at Hurricane Labs, we decided, hey, new 0 day, huge vulnerability, breach disclosed. Let's go ahead and design a use case.
And that situation where something happens, you need to design a use case is exactly what we're going to be talking about today. So our agenda for today, we're going to be covering the process of developing a use case, basically from first getting that data into Splunk all the way to confirming that it's working properly. And then we're also going to introduce you to the continuous improvement process that we have at Hurricane Labs, where we go from, hey, we get our data in, we have alerts, but how do we make sure those alerts are still working? How do we make sure they're effective in a customer's environment? And all of that. And to lead this webinar, you have myself, Tom, and Meredith. I am on the Splunk side, so I'm going to be focused more on the getting data into Splunk and making sure it's able to be used effectively for alerting.
And then I'm on the security side. I'll handle the use case development, how we go through and tune that, and then talk about, the improvements that are made after we set a search live.
So let's get started. So use case security development. What is going to be something that drives that?
So you've got lots of reasons to drive different security use case development. First of all, and the most common that we see is either you or we as Hurricane Labs identify a gap in coverage.
And that could be something where there's a product that you don't have. It could be an environment in your infrastructure where maybe you're not monitoring something, all those sorts of things.
Next up, you've got a discovery of vulnerabilities, either a 0-day, like we just talked about, security bulletins that come out, any sort of FBI flash briefing, or just anything that our tier 2 or tier 3 sees as a potential useful vulnerability that we should create a detection on.
You could also buy a shiny new product or tool. That's something that provides more visibility to your environment or provides a new functionality or feature that you didn't have before. And that's something that could drive a new use case.
We also see new use cases driven by breaches, which is, gross, never a fun time. But if it happens and there's something that slips through the cracks, there is a great example and place for a use case to be built to make sure that that same situation does not occur again.
You might find there's a software update and the developers include some lovely new features, aka bugs, that end up driving more use cases or potential vulnerabilities that need to get addressed. So that's something we see sometimes too.
Any sort of potentially anomalous behavior as well, either insider threats, risky users, just people doing things they shouldn't be, or things that would be outside of their typical job role.
Your MSSP,
Hi.
they could recommend some additional use cases from their experience working with other clients in similar verticals. So let's just say you're a financial services customer. We have a bunch of those. And if you're just one of those, you get the benefit of all of the use cases we develop from all of those other clients. Same goes for things like manufacturing and other verticals where we work on things for their specific use case and have the advantage of that scale.
And then last but not least, your CEO has read half a sentence in an article, or maybe even just the title of an article and goes, cool, I want that.
It's usually half the title, but yeah, that is something that we often see driving use cases as well.
Okay, great. So we've got some security use case ideas. Now what do we do? So first and foremost is we prioritize the use case development. So the highest priority use cases are ones with significant business impact, active exploitation, and for us, we also prioritize any sort of ask that the client may have here at Hurricane Labs. And just as a note, Hurricane Labs are going to often deploy use cases associated with any active attacks automatically across all clients, so that when something of the nature of MoveIt or Log4j back in 2022, where I'm pretty sure that 2/3 of our SOC got zero sleep based on the number of times that alert was firing off as a true positive, as well as the places where we discovered that that was deployed. And that was a really fun one just to see industry-wide. Everybody was feeling the insanity of that, and everybody came together to develop use cases, to help pick out more IOCs, to tune the use cases that people had been developing. And that was something that we had the luxury of being able to push out across all clients to make sure that if there was active exploitation or attempts going on in their environment, we could alert them to that efficiently.
And the same thing would happen like tomorrow. Hopefully this doesn't occur, but if there's like a Microsoft 0-day that's announced, like, yeah, we don't want to even threaten that fate.
We just had Patch Tuesday, please.
But if something like that were to occur, we're going to develop a use case and all of our customers are going to get that because that's the right thing to do. And that's what we're here for.
So in your prioritization, next up, you've got your lower priority. Those are use cases that you know that you want to have in your environment, but you may not have all the data available for just yet, or you know that there's some additional tweaking or configuration that may need to happen on your side. And of course, there are priorities in between these two, but those are just the two highest levels that we'll be talking about today. So for use cases, you're going to go ahead and
you got to make sure you have the data. So obviously, before you start a use case, you have to have the data in Splunk. If that's something you need help with, hey, we can help with that too. But if you don't leverage a product or tool, don't just turn on a use case because, hey, it looks cool and let's run the search, because you're wasting resources in that case. If you're running a Splunk search constantly looking for something bad, and that something bad is simply that your data would never have, you're going to be burning up resources, especially if you're using the workload or SVC licensing model for Splunk. That's something you want to be cognizant of.
All right, awesome. So
you've identified a priority use case. Can we have alerts? This is what always happens. We want to have alerts right away. Well, soon you're going to have alerts. But before you can have those alerts, you need a couple of things first. First, obviously, since we're using Splunk for this, data has to be searchable in Splunk. It sounds like common sense, but a lot of times it's like, oh, what comes first? The Splunk alert or the log source? It's the log source that has to come first. There's no chicken and egg question here. Data first, then alerts. And then the data also has to be usable in Splunk and normalized. So it needs to have good fields and good tags, basically using the Common Information Model or SIM.
So let's talk a little bit about the common information model and data models. So first up, congratulations, you've got a shiny new security project.
So that shiny new project or product resulted in your salesperson getting a new car. I would say if I was the person selling it, I don't sell anything here, but I'd appreciate a Rivian, so keep that in mind. But they're sure enjoying their new whatever it is.
Yes. So there are a couple things that we need to know to make sure that all of those log sources that you've got coming in now are common information model compliant and going into data models if need be. So first we need to know, what exactly does this product do? Is it a firewall? Is it some sort of endpoint detection device? Is this just, something special to your business? But we need to know at a higher level exactly what this does so we can classify it accordingly. And then next, we need to know how you're leveraging that in your environment. Is it a wonderful, shiny new bell and whistle that you've stuck on a pedestal and you're not necessarily implementing yet, where there aren't necessarily going to be a lot of logs? Is this something you've only got in development, or is this something that you've deployed for production and it is actively protecting your network in the sense of a firewall? We're also going to need your name, date of birth, last four of your social, all the standard stuff as well. And then, of course, any documentation surrounding the product. And that would be if we don't necessarily have that documentation on hand as you've purchased the product. And then we also need to know just one other question, and that's just if this is replacing another existing product that you have. For example, if you're switching to Palo Alto from a Fortinet device or something of that nature. And then if you had any associated use cases for that, we would go ahead and look, but also appreciate when others do a look as well, just to have that double second eyes on something.
And the goal here is maintaining coverage. So if you had something you're already doing, we want to make sure that we're still covering that as well. And if you're replacing something, things might change a little bit. Some of the detections might not be the same. Some of the logs might not be the same. Common informational model would hopefully help with that, but it's not always the case. So we want to make sure there aren't any surprises when you're replacing something. So one thing to remember, we're experts in Splunk and security, but we're not experts in everything. As much as we want to try to learn everything we can or be experts about everything, security and Splunk are our bread and butter. We might need some help from you to understand what the products do in your environment, how something in your business operates so that we can develop the best possible use cases. And that's really the consultative approach that we take to ensure that we understand the customer, we understand what you're using, and we develop the best security plan for you that we can. So I mentioned getting data in Splunk and making those logs available and exist is going to be the first part. That is the what comes first. But as part of getting that data in Splunk, we need to ensure that it is set up properly and valid. Couple of key things to keep in mind. You want to ensure that your data has correct line breaking or event breaking so that we know when an event starts and when the event stops so that we can identify, hey, each of these parts of a log is a separate event that needs to be treated individually. And then we also need to worry about timestamps. Where does the timestamp occur? And also ensure that that timestamp works properly in Splunk. That's really important for correlating events because if you don't have proper timestamps, obviously you're not going to be able to tell when something happens. You also want to ensure that the data is in the correct data model for the type of alert or the type of data it is. So like your firewall logs need to end up in a network data model. Your things with authentication need to end up in the authentication data model. Name resolution ends up in DNS. So all those sorts of data models need to be applied correctly so that the correlation searches that run on a certain data model actually are looking at the right data. You also want to ensure that your field extractions are correct. Is a source IP address, is the field actually existing with the proper source IP field? Do you have an action field that matches the common information model? Are we doing the right protocol? Is the user actually extracted? And is that something we can map to assets and identities properly? That way, whenever something fires, you dig into the log, you can see, oh, it came from this system. This user was logging in. They failed to log in. Okay, we know everything about this event just by using the fields. You also, this seems self-explanatory, but you want to make sure the correct users can search the data. Can the SOC analyst actually access the data? Are there any index restrictions that could prevent that from happening? Making sure that's not a problem. And you also want to understand limitations around data ingestion, such as there's throttling or delay in events. This could be something like your Microsoft 365 logs, where there can be up to a 24-hour delay before that data becomes available in Splunk. And that's really important because if you write a correlation search that only looks back 5 minutes, and it takes an hour to 2 hours to get that data to show up in Splunk because of how that API works, you're never going to get an alert for that data, even if horrible, horrible things are happening, because that search window is after the event would be ingested. So you need to adjust your lookbacks to make sure that you're capturing the whole range of data, and that's brought into your environment in a way that the alert will actually work.
So one of the tips that we like to suggest to our clients, and we like to leverage as well, is to compare sample data that you have in Splunk to the native mechanism for reviewing those logs on whatever the product is to ensure you're getting the expected events and all the relevant fields. And I'll pick on Palo Alto because I love to pick on Palo
You
Alto.
do that a lot.
I do love Palo Alto primarily because I get to use it on a daily basis for fun.
Fun.
But
Fun.
yes, fun for me, not for you. But with Palo Alto, you can go into the firewall interface and look at the events that are coming in there. And you want to make sure that you are seeing the same format and those same different fields that you would get in the Palo interface by default. So a source IP address, a destination IP address. If there is a DNS name, you want to make sure that's there as well. If you've got a username, you want to make sure that everything you're seeing in the Palo interface is also ported into Splunk. So that as you're searching in Splunk, as you're building out those use cases, you've got all that data there and ready, and you don't have to go pivot back into another product to get that information.
Yeah, and one of the reasons we do that is because you're familiar with that product, you know what to expect, and there sometimes are configuration changes that you need to make in order to bring that data in and to get everything that you need. So doing that up front saves you time and suffering later. One of the other things I recommend, so tip number 2, is to trigger a relevant event and basically simulate the thing that you're trying to detect and see how quickly that event appears in Splunk. So that would be looking for a delay. Do you get it in Splunk in a couple seconds, or does it take a couple minutes, or does it take a couple days? Hopefully not a couple days, but at least you know what that event delay is. You also want to confirm everything in Splunk has everything you need to basically reproduce, investigate the alert, understand everything that's going on. And if there are configuration changes that you need to make, such as enabling additional fields or increasing the log verbosity to get everything you need, go ahead and do that now. That way you know everything is going to get into Splunk.
Okay, so all of that data, thank you, now looks good. Now, what do we do with that? So first, we're going to go ahead and decide what detection is going to be most beneficial for us to begin with. And we are immediately going to dive right into the deep end. So if you are new to writing security use cases in Splunk, the first thing that you're going to do is start broader. And I wouldn't necessarily go index star and something in quotes, but you're going to start with the index source type where you know that data is, or leveraging those data models to make it as efficient as possible. And then go ahead and leverage those common information model SIM fields that you did all that work to set up, which we greatly appreciate. And then next thing you're going to do is give that search a nice simple schedule, let it run for a couple days to start generating some live results. While this is running, you're also going to pop open a new tab and you're going to take a look at any historical data that you've brought in to ensure that you would have gotten accurate results over the last 30, 60, 90 days if you've either already had that data in or whatever you were able to pull from a product to make sure that if you had something running historically, it would have given you those same accurate results that you're looking for now.
So Meredith, let's look at some potential use case ideas because we're talking about use cases. What are some ones that we think are cool?
So first and foremost, one of my personal favorites, just talking through exfiltration, is user sending an email to either with an attachment to either a Gmail domain or some sort of personal domain that isn't company or business focused.
And sometimes you might want to see something like a large number of Kerberos failed ticket requests. So essentially, are someone trying to log into a system and do it in a malicious way?
Next up, traffic to a known indicator of compromise or threatening IP address, domain, or file hash.
You could have an email that was identified as phishing via one of your phishing tools, and also an action that someone clicked on the link, as well as some activity showing, hey, the machine reached out to a domain that might have been on one of those threat IOCs. That's obviously something that could be worth looking into, we'll say.
Also looking for logins from an unexpected or new location for an individual. They may be on vacation. They may have randomly moved halfway across the world 20 minutes ago from when they last logged in at their desk in New York.
You could have an encoded command detected in your command history. This is a little bit of foreshadowing and something we might be looking into a little bit more as part of this webinar. But that might be something, hey, it could be a thing that your team is doing. But typically when someone's trying to hide something in a command, it might be something a little sketchy.
And then, of course, last but not least, any use case ideas that are centered around insider threat. That's something that I am definitely biased toward always wanting to create, just because I think insider threats are awesome and the ways to detect them are always going to be new and fun.
So insider threats are not awesome, but detecting them is something we can be
Yes.
beneficial. We don't want to have people have insider threats, but we
Fair
want to help find those. So some tips for writing detection searches. I'm going to go ahead and put on my fez here and talk about Splunk stuff for a second. I'll take that off because it'll get annoying. But you leverage your common information model fields when possible. Basically, that allows you to work with different products and source types. The goal here is you might not always have the same firewall. Maybe you're using Palo Alto right now, but Palo Alto annoys you, you switch over to Cisco or something like that. And you want to make sure the same use cases work on those logs. And common information model will let you do that because you're using the generic fields that are product agnostic. You also want to use macros where possible to make your life easier. And this allows you to specify like an index or maybe a source type. And using those macros, you can tweak the macro and not have to adjust 10 different searches. So that works a lot easier and can also be leveraged for suppressions as well. You want to work with real data when possible, especially if you can get sample data that includes the thing you're trying to detect. That way you can actually be working with real events as opposed to trying to make some data. And then finally, well, not finally, but second to lastly, you want to consider your search efficiency and performance. Writing searches in Splunk, there's ways that you can make them more efficient. There's ways you can make them less efficient. So things like wildcards result in Splunk hitting a lot of different pieces of data, and that can result in slower search performance. You think about a detection, it runs every 5 minutes or even more frequently. Any sort of thing you can do to save resources is important. Also, things like leading wildcards kill search performance. So anything you can do to avoid that sort of thing in a detection search is something you want to try to do. And also, I mentioned this earlier, but consider your ingestion delay. So you schedule around how long it takes to get data into Splunk. And if you know it could be up to 24 hours to get that data into Splunk, you need to write that search to run over 25 hours to make sure you grab those new events. And that's how understanding the limitations of whatever your product you're working on is really important to ensure that that data comes in. So off at the fez, we're done talking about that. I'll hand it back over to you, Meredith, for tuning.
Thanks. So now that we've got a search written, we're going to go through and talk about our tuning process. So for our tuning process, our goal is to always increase fidelity and decrease the false positives. So if you make your search perfect from the start, which we'd really love to see happen, you'll never need to go through this process. But we know reality says that's not really how it works. There's always going to be something. There are always ways that we can go ahead and improve a search. So if you're one of our clients, you'll see that we tune and we tune often, whether that be our tier 1 and tier 2 tuning something based on feedback from an alert, or our architect and use case development team tuning something either before a search is set live or with a new release of a search where we're completely overhauling to increase the fidelity of a search. So if you're not one of our clients, you may be asking, what is tuning? And if you are one of our clients, you may be also asking, what do our architects do on the back end that you may not be seeing? So once we've got a search, one of our architects will go in and click deploy, and they'll have that search start generating notables, doing everything that we talked about before. And then they're going to play video games for about 3 weeks. And those video games are actually the tuning game. And it's a lot of fun because you're like, okay, I've got a search. I've got hundreds of results here. Say we've got 100 results. 91 of these are false positives. So we're going to look for ways to tune those out of the search as known false positives. And then we go ahead and keep doing that game again and again and again and working directly with our clients to say, here's what we think are false positives based on our knowledge, either within your industry vertical are knowledge as security professionals. Here's what we think. And, we get feedback from our clients saying, yes, these are known false positives in our environment as well. Or actually, some of those are true positives because we're not leveraging either a feature of a tool or something in Windows that might be causing a false positive, or in this case, a true positive. And we'll see some true positives happen within that tuning process before a search is set live and make sure that we are investigating and supporting as well. But if there are no alerts that have happened within that window, then that search is good and ish, good enough to be set live for the first round. So we go ahead and call it a day. And this is what we like to call the ship it method. No alerts. We've seen nothing over the past historical window. Great, ship it, set it live.
So what does a good alert look like, Meredith?
So it looks just like a bad alert, annoyingly enough, but with way more data to pivot into so that you can deep dive further and be able to get more information from within your Splunk environment to provide some good context and figure out exactly what's going on. And also, that alert detail that you're getting isn't automatically seen as benign or expected activity. So it's not a false positive from the get-go, and you either need to do some searching to figure out it's a false positive, or enough searching to provide enough context to escalate something over and figure out exactly what's going on and work with your client.
Yeah, the last thing you want to see is alerts that pop up, and if you have dozens or hundreds of alerts and they show up and it's like, oh, this is just noise. We don't need to do anything, because that just encourages alert fatigue and you're not going to be taking alerts seriously. Which leads me right into the next topic of more alerts are better, or more better, right? More alerts. We want more alerts, right?
No. So I wouldn't say more alerts are always better. So the alerts that you want to have firing in your environment should be actionable. And that is something where, as Tom was just alluding to, an alert generating about 10,000, 14 million alerts per day is likely just going to be noise that nobody's actually investigating. Nobody's drilling down into those events. And people are just kind of filtering that out as background noise. And you're getting alert fatigue from your analysts for it.
But if something is generating that number of alerts, it still has some value, right?
Yes, it definitely has value. It's just that that's a really good candidate for risk-based alerting. And for risk-based alerting, which is something I know that we will delve deeper on later into the year, each alert that fires increases the risk score for an object that's either a user or a computer, and those alerts are investigated as a risk score crosses a target threshold. And we work with clients to determine what the risk score is for each alert that factors in, as well as any base scores for objects, especially ones that are of higher severity, like a CEO or your domain controller versus an endpoint that's completely segregated from the network, or somebody who works in dev and only exists in a lab environment.
And then something to keep in mind, when you have unnecessary alerts or use cases that are running that aren't beneficial, you could run into performance issues. It might delay your ability to not only deal with things from can your analyst deal with that in their performance, but also even from a compute perspective, there could be some challenges there. But I would say the biggest issue performance here is going to be the performance of your people dealing with a large number of alerts that they can't take action on, and potentially if you have 10,001 alerts, one of them is bad, find it. Your needle in the haystack approach is not going to work that well.
All right, so we've got the data in Splunk. We've got our detection search built out and it's live, so we're getting alerts. Now, what do we do? So the first thing that we need to know now is how to respond to an alert. We need to know who gets notified and how they get notified. And then, within that, when do we need to call people to wake them up in the middle of the night if something were to fire off hours? And then internally as Hurricane Labs, we go through and we develop a playbook for investigating an alert. And that playbook is everything from, this is the base information that you are getting. Here's where you want to start. Here's why this alert fires. We give our analysts the purpose, some high level investigation info, and then really give them the ability to run wild and dip into whatever different areas they need to come to a determination to escalate that alert off to a client. And then if they see any false positives and consider it a great candidate for tuning, they'll kick over a tuning ticket to our tier 2. And then, of course, last but not least, we develop an automation SOAR playbook for any sort of initial triage or response actions that we might need to take. And you'll see that for clients leveraging our SOAR services, it's easier for us to get through something faster because we're able to respond faster by leveraging SOAR and SOAR playbooks.
And once you have, your response plan, your automation, you probably got to do some testing, right?
Yes, test, test, test. That is one of the things that we really love to do here. So you're going to go ahead and test the entire use case process from start to finish. So first off, you're going to go ahead and trigger an event. You're going to validate that that data goes into Splunk and the associated notable event fires. Next, you're going to confirm that the relevant response actions were taken, whether those are automated through SOAR or those are manual actions that an analyst is doing either on the Hurricane Lab side or on your SOC side. And then for a more mature security environment where you have the ability to leverage either a pen test or purple team, you can have them go through and validate the detection as well, and also see if they can try to evade that detection to know where you also want to keep tuning that search and shore up more of your defenses.
And like purple team is super useful because that's something where the goal is to identify gaps in coverage. And hey, purple team finds something that, hey, we might have detected something early in the process. Great, but maybe something further down the process is something that we need to collect more data for. And that's the great approach. When you're doing these sorts of things, there might be some pros and cons to identifying, informing insiders, letting us know ahead of time, making it a surprise, and then working through things later. That is all fine. It's great to find out. The important thing is that we work together to identify what was discovered, what gaps might exist, and just improve the overall security posture of your environment.
So the way that the security use case development lifecycle works is that it's kind of like the water cycle. You're never going to have it just be a start to finish rainbow. It's really going to be a continuous cycle where you go back through and review and evaluate. So on a regular basis, now that you've got a correlation search live, you are going to want to go through, confirm that data is being properly ingested into Splunk. And then, of course, no version changes of any TAs, anything of that nature have impacted the quality of data, or if something is broken, you're going to confirm that those searches are running as scheduled.
You're going to confirm that alerting process and flow to make sure the use case is functional and relevant. So does an alert fire? Is the use case that we're having relevant to the product in our environment and all of that? You also want to assess if there's any additional changes to the environment that might be things that happened and account for them. So maybe you got a new product or a new tool. Maybe you got an infrastructure change. Maybe you acquired another company. All these sorts of things could result in something changing. And obviously, if you identify that, go ahead and add that.
So let's talk about when you go ahead and deprecate a use case. So first off, and this is the most common one that we see here at Hurricane Labs, is a vulnerability is no longer relevant to your environment. And that usually happens when you're no longer leveraging a product, or you've finally been able to make the business case for sunsetting some old software. And you're saying, okay, we no longer have Windows Server 2003 email server in our environment, as somebody who definitely doesn't have one of those in their house.
Not anymore.
Uh-huh. Sure.
Or like move it. Let's just say you got rid of that product. You don't have to worry about searching for it anymore if that's something that's been removed.
Yeah. Disable the search, keep it there just so that you still have the syntax and logic, but make sure it's not wasting precious resources in your environment. Next, the data sources you have supporting a detection no longer exist, whether those be because you've changed products or because you've completely shifted gears. You always want to make sure that you are keeping the security use cases you have live relevant to what you're actually detecting.
And then last but not least, you could have a case where a use case was superseded by a better one. So you rewrote a search, there's a better detection. I think there's several in Splunk that we've worked with for that, especially around like geographical improbable logins and a couple other of those. So you don't want to necessarily have multiple use cases that all do the same thing if you have one that works way better.
Yeah, and if I recall correctly, I think we're on our 7th full rewrite of that geographically improbable search.
So we're not running all 7 at the same time. We're running version 7, and that does what we need. So we've walked all through that from a theoretical perspective. Let's bring this all together and walk through an example from bringing data into Splunk all the way to making an alert happen. And I think that'll really drive home this whole process. So our development process, we're first going to bring that data into Splunk. We're going to develop a detection search. We'll confirm that alerting pipeline is working properly. And then finally, we'll validate the efficacy of that use case.
All right, so congratulations. You've now received a new tool. And this one, sorry, your salesperson didn't get their shiny new Rivian for, but you've got Sysmon and process logging logs in. So this data is really a wealth and treasure trove of information about anything happening on a system. And there's both Sysmon for Windows and Sysmon for Linux now, which I am a huge fan of. And that information is really beneficial in investigation, especially for detecting any sort of unusual system behavior that may be occurring. And I will say that it is not a data source that we see often, but we'd love to see more of. And there are ways that you can work it into your environment where you only have that data deployed on a critical subset of systems, but make sure that you get that depth there where you need it.
And it's a super useful use case to have this data. It's something where you don't have to buy another product. It's something that is built into your operating systems or can be added. So we love to see it. There is the caveat of it can be a high volume data source. So you might have to prepare for that in terms of data ingestion, but it is something that from a SOC perspective is super useful, and we'd love to see it in more investigations.
So now that you've got your product, here's your use case, one we may have alluded to earlier. You are looking for encoded commands being detected in the command history. So the relevance of this is it's a pretty common malware technique for obfuscating payloads and either getting data in or exploiting something out. And then you've got a business use case associated with that. You want to detect against potential exploit attempts that are going against your endpoints and any servers you have in your environment. And then, of course, as I just kind of brought up, you've got a bonus business use case. You can detect data exfiltration or infiltration with those encoded commands.
And this is something where you generally shouldn't be seeing that, but there are cases where, hey, someone might be using an encoded command in order to, a script they wrote or something like that for a business process. So that's a case where, hey, it might be something you're using, but if your alert detects, hey, this is something that we use as part of a business process, first ask why, and then you can tune that out. So there's a couple data onboarding steps that are going to be involved here. And the cool thing is Sysmon for Windows or Linux is something that there's Splunk-based apps that exist for. We'll paste the links into chat so that you can grab that as well. We also have a tutorial where we walk in how to work with setting up Sysmon, and that'll walk you through the whole process. Another part that's super useful is to have PowerShell transcript logging enabled. And that basically is a full transcript of all the commands that are run in PowerShell and gives you details about potential threats that might exist there as well. We also have a tutorial on the screen there of how to get that information, as well as an app that we developed that makes getting that data into Splunk a lot easier. So let's start by data onboarding. The first thing that you need to do is to enable Sysmon on your systems. And basically, you want to use the right kind of Sysmon config for this to ensure that that data is useful. You don't want to have too much data that isn't necessarily useful, but that's driven by the Sysmon config. Obviously, the data needs to exist before Splunk can do that. So you apply your Sysmon config that's relevant to your use case. You install those Splunk apps. So the Sysmon apps, the PowerShell transcript log app, we will add those. You'll create inputs, whether you're doing that on universal forwarders and pushing out via the deployment server or some other method. Doesn't matter. You want to get the data into Splunk. Then once that data is flowing into Splunk, you're going to actually confirm that it's working properly. You're going to confirm your field extractions, make sure the data is available, all that good stuff to make sure it's searchable. Now, for PowerShell transcript logging, you want to enable PowerShell transcript logging on your target systems. Follow our tutorial on how to do that. The data obviously still needs to exist in order to do that. You want to install the Splunk app for that. You create inputs. The tutorial walks you through some of the gotchas for inputs on there. This is a little bit of a weird data source because you are kind of relying on potentially human input and want to grab the entire transcript properly. And you'll validate your field extractions and your availability of data, and that'll all show up into Splunk. Yay, we have data. Now what do we do?
Cool. So now it's my problem again. Awesome.
Yes.
So we go ahead and develop that use case search. So that's what problem are we trying to solve? We're trying to solve for the fact that we currently can't detect obfuscated malware payloads. We're also looking for exploits against servers and endpoints in our environment. So how do we accomplish this? We're going to go ahead and hunt for some encoded commands.
And one of the really cool things about that PowerShell transcript app, the person who developed it, hi, uh, did a lot of research actually into some different options. So there are field extractions and event types that are built in for a lot of common PowerShell attack vectors. And the great thing about that is it makes developing a search quite a bit easier because some of that stuff is already accounted for. I won't say they're the prettiest searches because I'm not a search developer, but it's something.
But they do work. And here's an example Splunk search and the one we're going to run with now. And that's index equals PowerShell, and then tag is encoded command. And as I said, start broader. So that's where we're going to go ahead and start before we use any tuning and go through the rest of our use case development lifecycle.
Yeah, and the cool thing about this, you don't have to know what to look for an encoded command because the logic is already part of the TA. That's something we developed already, but other products might not have the same sort of thing. You might have to put more logic into the search as well.
So congratulations. Now you're going to let that search run and have it try and generate some live results, but you're not going to have that set to alert your SOC yet because you don't know if there are any false positives or not. So you're first going to run that search and over any historical data that you've got, whether that's 2 or 3 days as you've been building out the search, or maybe you've had Sysmon and PowerShell transcript logging in your environment for a couple months. You've just never leveraged it for use cases, but you're going to run that search over that as well. And then you're going to identify any occurrences where an alert would have fired. And from there, you're going to take a look at those alerts that were created, and you're going to go ahead and identify some false positives in there, if there are any. So as an example, sometimes encoded commands are part of normal business processes.
And we did see that like at one client where we rolled it out, there was a tool that they used for, I think it was system inventory or some kind of basically package information across systems. There was an encoded command in there. We saw that fire hundreds of times across all their systems, like, oh, we need to look into what this is. It's something that is a legitimate business process. That's something we don't need to worry about. And that's something, we might ask why, but it would make more sense not to, but sometimes there might just be a case where that comes into play. But you tune the search to account for that.
Yeah, awesome. So now you're going to go into tuning your alert for encoded commands. So search is written. You've got your obvious false positives. Those are accounted for. Now it's time for some fine tuning. So you're going to review every single alert that's generated more recently since your last round of tuning and remove any minuscule, 1-off, 2-off false positives that you may see in there in those results to try and increase the fidelity and decrease the noise that once you set that live, your SOC and your analysts will be receiving. And then you're going to run that alert over several weeks, as much historically as you can, as well as 1 to 2 weeks currently as you're developing, to account for as much of any normal business activity as you can. And you're going to go back and repeat this cycle and do fine tuning as you tune out more and more of that normal day-to-day business opportunities that you see. So congratulations, you've completed all your fine tuning. Now you're going to move into the live alerting. So you're going to set that alert live. Your SOC's now going to respond to any events that trigger, and we can assure you that they will be notifying you if they see false positives because they want to tune those out and get the highest fidelity alerts as well.
And then finally, now that we have live alerting, everything looks great. We have our use case going. Alerts are being generated, bad things are being found. But that's not the end of the process because continuous improvement is going to be really important to ensure that you have a good life cycle of your alert and it maintains its relevancy and effectiveness over a long period of time. So you revisit that tuning cycle on a regular basis. And you're going to also get feedback from your analysts as they investigate the alert. If they say, hey, there's this sort of event that always happens at this period of time, like 5 a.m. on Saturday, we get 100 alerts all the time. Like that's an obvious example, but hey, there's no reason you should be bothering that unless there's a piece of malware that runs every Saturday at 5 a.m. That's something you definitely want to deal with. But if it's something that is triggered by the something we didn't expect or didn't see, or someone changes something and it results in a false positive, you want to make sure you're integrating that feedback as well. Additionally, you do maintenance in your environment, whether that's OS maintenance to do security patches, whether it's Splunk maintenance where you upgrade to a new version of Splunk, have as part of your maintenance process validating that functionality, making sure the alert pipeline works so that it goes to your SOC properly and that those sorts of things can occur. And then also leveraging your purple team or pen test to validate alert efficacy is huge. And even more important from just validating that is getting feedback, sharing that with your provider, in our case, us, so that we can get better and identify, hey, are there improvements that we can do to make this work better for you and give you the best possible coverage that we can?
Yep. So now we've gone through, we've seen the full life cycle of a security use case from its development to its being set live as an alert to any tuning that may have occurred either before or after it was set live. And we didn't cover deprecation in this because we think that encoded commands are something that you should always want to monitor for unless you switch to a Mac OS only environment, and then you're going to find a different and interesting way to develop that use case.
But like if PowerShell goes away sometime in,
Please
some
don't.
number of years and they develop something better, like then your PowerShell use cases aren't going to be that useful. And there's something else.
Fry my PowerShell from my cold dead hands. I run PowerShell on Mac. That's how much I love PowerShell. But if all of this seems overwhelming and there's a lot to that tuning process, you're saying, okay, wow, there's a lot of work that goes into each use case that's built out. That's completely okay. That's why we're here. That's why we have a team of individuals who are very passionate about security and building out use cases to detect threats in your environment.
Yeah, and we can definitely help with that. That is, like Meredith said, that's why we exist. Helping customers work through security use cases, all the way from bringing data into Splunk to developing alerts and handling those alerts and helping you identify security problems in your environment is what we do all day. So reach out to us and we're happy to help you figure out the best way to handle all the security use cases that you need to get developed. And with that said, we will open the floor for any questions. You can use the chat functionality in Zoom for that. Doesn't look like we have any so far, but we will definitely look forward to any questions you might have, because there's no way we answered all of your questions. It's just us talking for 45 minutes.
You can also use the Q&A function if chat is not working.
Yeah, it looks like chat's disabled. So yeah, Q&A is how we'll do that. Thanks for letting us know, Scott. Someday I'll learn how to configure Zoom.
Today is not that day. Are there any questions you have? All right, we got one mild haha for entertainment. Yes, we
Yes.
did something fun.
Yay. I think that's commentary on my inability to configure Zoom, so we'll
sounds like
we'll go with that.
You problem. All right, we have a question from Kenny, and Kenny asks, what's the strategy to get Windows Sysmon from mobile workforce, not on VPN? Ooh. So there are a couple different routes you can go. I don't know if you want to.
So I'm going to look at this from a couple different approaches. Clarifying question I would first ask, are you on Splunk Cloud or are you on Splunk on-prem? Because that's going to impact how that data actually comes in. If you're on Splunk Cloud, you can configure things like by default, Splunk Cloud has certificate authentication for universal forwarders. So anywhere that has internet connectivity, you'll be able to get logs into Splunk Cloud. So that makes that easy. You might still have some challenges with managing config on your universal forwarders. You could do that via deployment server and have that be something that is internet accessible. You can authenticate clients coming into deployment server and grab config, or you could manage that through something like SCCM or some other tool to be able to get those configs on those systems. That's an option. Otherwise, I've worked with clients too where you just have on-prem Splunk, and we've architected a solution where, depending on where you are in the network, Splunk sends data externally or internally. And if you're off a VPN, you'll still be sending data to either external IPs. You could be sending that data to elastic IPs if you're in AWS. There's a bunch of different options to ensure that that data routes all the way to Splunk. And then from there, you just have the ability to have those use cases. So there's a couple different design architectures for that. I can talk for hours about different ways to design Splunk ingestion for different types of things, but hopefully that helps a little bit with some of that strategy for getting data in.
All right. Next up, Camille asks, is it possible to find chain of execution without Sysmon? Yes, there are a bunch of other different tools that you can leverage. If you have a next generation EDR, such as CrowdStrike or if you're leveraging something like Sentinel-1 or Microsoft Defender with the full suite turned on, there are a lot of different areas where you can get the full chain of command execution and also see the process tree. But from an open source perspective, Sysmon for Windows and Sysmon for Linux have really been the best thing that I've seen so far. I don't know if you've
Yeah,
seen any different.
I think I'm always, I wouldn't say skeptical, but I hate recommending specific products, especially if it's like, hey, go buy this other thing, because you don't know the situation of any given, end user or customer. So we like to leverage things that are built in because it has that flexibility and you can make a recommendation. Hey, this is something you can turn on and it's going to work. But I would say same sorts of things where you have like EDR type solutions. The amount of data they suggest varies, I would say, depending on the product, but I think we've seen good luck with CrowdStrike and some others for that.
I will say, as a red teamer for fun and outreach, Sysmon is usually the thing that catches me most, which both, endears me and causes me to love it from the security use case design perspective. But as a red teamer, really, really frustrates me because when I'm working, somebody will know exactly what the command was that I ran and from where and exactly what I was trying to hide.
Yeah, I guess an alternative could be potentially like wind process monitoring too. That's something Splunk can do where it logs all of the process information. That's also a lot of data, but it can be really effective to see that sort of information that happens. Okay, we're not seeing more questions, so we're getting close to the top of the hour. We definitely appreciate everyone tuning in and listening in. I would say keep tuned to the Hurricane Labs website. We'll be having more webinars in the next several months that we'll be happy to have you join. Scott, you have a question about who to contact us. There's a contact form on Hurricane Labs website, hurricanelabs.com. And you can just submit a question there and they can route that to the right team on our side, which will be potentially me, Meredith, some other folks from our technical team for all of that.
But also as a shameless plug, both the blogs we put in here through chat as well as the rest of our cybersecurity blog with Splunk tutorials, about 2,000 of which have been written by you.
Less than that, but
Close enough. A bunch of different blogs on security use cases. We do have another one on Sysmon. There are 2 other parts to that Splunking with Sysmon series. Those are all available at hurricanelabs.com/blog or /cybersecurity blog. So you can always go there as well to just grab information from us.
And we love sharing information and helping you all be better empowered to work with Splunk. We also recognize you can't do everything on your own. So if there's something that you need help with, we're happy to do that as well.
All right, next question is from Michael. We have a very detailed audit deconfig, but would be interested in using Sysmon for Linux on some of our systems instead. Are you aware of any resources for converting an audit deconfig to Sysmon? That's a good question. I think most of the times that I've set up Sysmon for Linux, it's been on a relatively fresh system where there hasn't been a lot of security resources enabled on the Linux side, and people are really usually more focused on Windows and the domain. So by the time that we are suggesting configurations for Linux, it's coming through as more of a fresh security clean slate.
Yeah, I'm actually very happy to hear that someone has a good audit deconfig because that's not something we see a lot of, and I'd love to see more of that. So don't really have much to go on beyond that, but like, yeah, if maybe we could figure some out way to like, hey, show us what you have for audit D. Maybe we can see if there's something that we can translate into Symfony for Linux that could be useful.
Yeah, and the parity in terms of event IDs and everything is pretty good, and they do have good documentation, which is something I don't think I get to say often enough. But there is pretty solid documentation on Sysmon and Sysmon for Linux, so that you can actually know, okay, if I configure this and I have this enabled, this is what I'm going to get from it. And Camille also asks, Sysmon takes up a large volume of the stream. How can we optimize our system without Sysmon?
So that kind of falls into the same strategy of how do you optimize any sort of log ingestion into Splunk, where reviewing what data you have that's useful, so to speak, from a security perspective to removing things that maybe aren't going to provide any value. So like one of the things we do when we're looking at Windows event logs is there's event codes that don't have, I wouldn't say don't have security value, but they're not something that's going to drive an alert. So those sorts of things we will basically either tell the customer to turn off the operating system, or the universal forwarder will drop those events so that they don't come into Splunk. Sysmon, you can review the same sort of events and set up configuration, whether that's ingest time or similar, so that that data doesn't end up in Splunk and you don't have to worry about the license for that. It's going to be event by event basis, and if you can turn it off at the source, that's going to be even better. But anything you can do to remove an event that isn't necessarily going to drive an alert, that could be something that reduces some of the volume that you have to ingest.
We'll hang out for a minute or so just to see if there are any last questions. Other than that, thank you all so much for hanging out with us. We greatly appreciate it. This has been a really fun hour or so that we've spent with you.
Yeah.
But we do have another webinar coming up in the next quarter. We'll start releasing information on that soon. It'll be a fun time again.
Yeah, I think we're going to be targeting RBA for some of that risk-based alerting. So that'll be something I know people are interested in, and we'll be able to provide some information about that as well. Thanks, Camille. We're glad you enjoyed the presentation, and appreciate you asking us questions.
Joe asks if there's a way to get notified about upcoming webinars. Yeah, we can certainly add you to our mailing list. Otherwise, I know that we post on LinkedIn, Instagram. I'm really bad at remembering all the social medias that we have. But I know that there are a couple different ways, but if you wouldn't mind sending me your email address directly, I'll be happy to get you added to our list so that you'll know of our next webinar in the next quarter.
And appreciate your interest, and thanks for showing up. We love it when people at the end of the webinar are like, I want to go to more of these, as opposed to, I never want to see those two people ever again. So that is great to see.
All right, and Jonathan says woo RBA. Woo.
Okay. Well, thank you, everyone. You all have a wonderful rest of the day, evening, morning, whatever it is. And we'll look forward to hearing from you all again soon. Have a great day.
Adios.
Bye.